Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science Engineering in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about minimum spanning tree, which is going to be solved through Prim's algorithm. So before going to see that, so what is the spanning tree here? So spanning tree of the graph is just a subgraph, so that contain all the vertices, and it should be a tree. So the graph may have many possible combination of spanning trees. So the spanning tree of the graph is nothing but a subgraph which is going to be obtained like v1, v2, and v3. So this is the one possible subgraph v1, v2, v3. This is another possible subgraph. So all the possible combinations should be considered as the spanning tree of the given graph. So for example, this is the given graph. So from this given graph, I'm going to be construct the different possible combinations of spanning trees here. So these are the different possible combinations of spanning trees. So in this one, so I'm going to this one spanning tree. So this is another possibility, and this is another possibility. So like this, I can able to draw different categories of different types of spanning trees as well. So if I'm going to consider it, so this is the one of the possibility of the spanning tree that I'm going to obtain. So if I'm going to join this, I'm going able to get the loop here. So that's why this edge is not going to be considered. And in this one also the loop is obtained. So this one also not going to be considered. And this one the loop is obtained here. So that's why this one also not to be considered here. So this is the one of the possibility of spanning tree. Similarly, if I'm going to draw this under one, so I have to check whether the closure loop is obtained or not. So if I'm going to construct these two, I'm going to get the closure loops. So these two edges are not going to be constructed. So in this form, if I'm going to draw this one, I can able to get the closure loops, right? So that's why I'm going to eliminate all these edges to eliminate the closed loops. So like this, I'm going to get the total possibility of spanning trees with the nodes 4 is totally 16 possible combinations I can able to get. So normally the spanning tree of the given graph is the minimum cost of the graph actually. So if the weights are going to be assigned, suppose if I'm going to have a graph like this. So in this graph, the the weights which is going to have minimum, so that thing should be considered in such a way that we have to visit all the nodes and which does not form a cycle here. So among these four uh, vertices, so what is the minimum one? First is one minimum, so this is another minimum I consider, and second one also I going to consider. So if I'm going to consider three, so I'm going to get a loop, right? So that's why this one will not be considered here. And similarly, if I'm going to take 4, again loop is obtained, so that's why this one also not to be considered. So the minimum spanning tree cost is 4, so this is the required minimum spanning tree here. So among this all the possible combinations spanning trees, the minimum should be considered in this one. And what is the Prim's algorithm here? So the Prim's algorithm starts with one node, and it then one by one adds a node that is unconnected to the new graph, and each time selecting the node whose connecting edge has the smallest weight out of the available nodes connecting edges. So mainly this algorithm we are going to start with one node, and then one by one have to connect it, and you have to add the node that is unconnected to new graph. So each time you have to select the node whose connecting which is going to have the smallest weight of available nodes connecting edges. Suppose if I'm going to draw one graph here, so initially I'm going to start here. So what is the minimum edge that is going to connect it? So that's why I'm going to consider as ABCD. So A is next minimum. So among this B, so I have two options. So one is 2 and there is 5. So I'm going to take the minimum. So B to D I'm going, and from D I'm going to have two options here. So one is 1 and another is 4. If I'm going to consider 4 here, so I'm going to get a loop. So that's why this edge will not be considered. What is the another option? I'm going to have this. So that is 4. So 4 is going to be considered. So the minimum cost is 7. So this is the required minimum spanning tree according to the Prim's algorithm. So what are the steps in this one? So the new graph is going to be constructed with one node from the old graph, and while new graphs have fewer nodes, then find the node from the old graph with the smaller one connecting to the new graph and add it to the new graph here. Okay, so initially a new graph is going to be constructed with one node from the old graph, and while the new graph is going to have fewer than n nodes, so first find the node from the old graph with the smallest connecting edge to the new graph and add it to the new graph here. So every step we have to join the one node such that we'll have only one graph with all the nodes, and it should be the minimum spanning tree of the original graph. So every step is going to be joined by one node such that at the end we have only one graph with all the nodes, and it will be the minimum spanning tree of the original graph here. So let us consider this complete graph with the known weights. So I have to construct minimum spanning tree in such a way that according to the Prim's algorithm I have to construct it. So for this initially I'm going to construct a new graph in such a way that, so among this starting I'm going to construct is A. From the starting A I'm going to have two options. So one edge is the weight of one edge is 1 and the weight of another edge is 4. So among these two I'm going to consider the cheaper one. So that's why I'm going to consider A to D. So once I visited A to D, so then I have what are the options that is going to be considered. So I have three options: 4, 6, and then 5. So among these 4, 6, and 5, so which is the minimum I have to be considering? So that's why I'm going to consider 4 here. And next one, so in B, so I have only two options. One is 4 and another is 10. So that's why the minimum is 4. So I'm going to consider 4 here. And if I'm from C, I'm going to have two options. So one is 2 and then 1. So next minimum is 1. So that's why I'm going to consider 1 F, C to F. So for F, I'm going to have two options. So 3 and then 5. So among these 3 and 5, 3 is the minimum. So that's why I'm going to consider. From G, what are the options? So 2, 3, 3, 4 is there. So that's why I'm going to consider the minimum one is 2, E to G. So E I'm going to be considering here. And next minimum, what I'm going to consider is I. So for this I, the minimum is 3, 3, 5. So 3 is going to be considered. And next one is J. So from J, what I'm going to set is that 3. So 3 in the minimum is 2. So 2 is going to be considered. From H, so no more options. So only 2. So 2 is going to be considered. So this should be the resultant spanning tree according to the Prim's algorithm. Okay. So in Prim's algorithm, so have to be constructed a new graph in such a way that, so we have to be identify the smallest edge weight first, and then from that node again have to identify the next small weight. So from A I'm going to discuss what is the minimum is 1. So that's why I'm going to consider A to D part first. So from the A to D, so I'm going to have four options. So 4, 5, 6. So among these 4 is the minimum. So I'm going from D to B. So from B, I'm going to C. What is the minimum? B to C is the option. So B to C. So from C, I'm going to have again 2 more options, 1 or 2. So I'm going for F here. So from F, again what I have to do, I have to check the minimum. So that should be 3 and 5. So I'm going to consider 3. And from G, 2 here. So from G, I'm going to have 2, 3, 4. So 3 is going to be considered. From I, so 3, only 3 is the only option. So 3 is J is going to be considered. So once J is considered, so next minimum is 2 and 6. So 2 only. So J to H. And this should be the resultant point of the given. So mainly this one is going to be used in costing the wiring of electronic components and shortest route between the two cities and shortest between the pairs of cities in a road Atlantis, matching and resource allocation and task scheduling. So mainly this kind of algorithms mainly used in many applications like finding the routes of the cities, finding the distance between the pair of the cities and matching resource allocation, task scheduling, etc. And this one also going to be used in flow of materials like liquid flowing through pipes and current through electrical networks, information through communication networks, and parts through an assembly line like this. So in operating system, we're going to model the resource handling, what we call as deadlock problems. So in compilers, we're processing and then optimizing the code. So we have to construct this. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.